Okay, this problem is really similar to the other ladder on a wall problem, except now we're trying to find how high the person can climb up, right? So we still have to start by writing equations for this. So treat it first like the ladder moving translationally, and then treat it like the ladder moving rotationally, right? So let's write our force equations, right? So net force in the x, it's not accelerating, right? That's the point. We don't want the guy to accelerate. That'd be bad. Net force is 0. So that's the weight, right? So I'm going to do this like we did the other way, right? Because I'm going to use the same terms. So it's going to be the force of the wall, right? The wall's pushing this way. So the force from the wall minus the frictional force, right? So the friction, let me do this in red so you can see. That's the force from the wall, and that force is going to be F, right? So the friction from the ladder should equal the wall pushing this way. The wall's touching it, so the wall's pushing, right? So minus, I'm just going to call that F for friction. Okay, so now let's do net force in the Y. Net force in the Y is also 0 because the ladder's not like flying. So that's going to equal, what other forces are there? So I haven't drawn the ground touching, so the ground applies a normal force, right? And there's also the weight of the guy pushing down, right? It's the same as that other problem. I'm putting the same variables. It looks exactly the same. So it's going to be normal force minus weight. Okay. And I can also write a torque equation, right? So my net torque is also 0. So that's same thing as the other one, right? So it's this sine theta minus that cosine theta. So it's FW sine, times d sine theta. So I'm going to call this d, right? So that's d. Okay. So let's do this. This is d, and we'll call this L. So the distance of the ladder is d. So times d sine theta minus WL cosine theta. Right? So now I got 3 equations, right? So D is this distance, L is the distance up the ladder. Okay, 3 equations. So okay, so what does this mean? This basically says, so I've got this one, and then I'm going to say FW equals F, right? From this equation, those are equal because 0 equals that, and then same thing here. If 0 equals that minus that, then that means N equals the weight. Okay, so I know those 3 things. So taking these 3 things, let's substitute. So let's start with that torque equation. So FW d sine theta. Because 0 equals that minus that, these 2 things have to be equal because they're going to cancel out to give me 0. So that equals WL cosine theta. Okay. So now the weight, right? The weight, I'm going to put in mg times d, right? So that's F. I know that frictional force is equal to the weight, and friction is mu mg, right? So frictional force is mu times normal force, so that's mu times Fg, so that's mu times mg. So mu mg times d sine theta equals W is equal to normal force, right? And W is mass times G equals mg times L cosine theta, right? All I did was substitute W becomes mg and FW becomes mu mg, right? So again, it started with this equation. So now, okay, look, mg, gone. They cancel out. Oh, look, this is kind of easy. That's an L. Kind of looked like a D and I almost got confused. So mu d sine theta equals L cosine theta. Oh, look. So, okay. So I know sine over cosine, right, from before. Sine over cosine equals tangent. That's a trig function. So if I can get the cosine over under there, then I can get tangent theta, right? So if I divide both sides by cosine theta, it's going to go away over here, and I get mu d tangent theta equals L. Right? And so now, I just want to get, so tangent theta, I'm going to divide over mu d, so L over mu times d is tangent theta. And again, if I want to solve for the angle, I can take the inverse trig function of all this. So I'm going to say theta is the inverse tangent of L over mu d. And that would give me the angle, right? The horizontal angle that I can get him to get that far up the ramp. Right, so again, if you can write these three equations, if you can identify the forces, write the three equations, like the rest of this just takes a little bit of kind of being clever and plugging in stuff, but it's just solving.